Starting with the great name of Allah, the most merciful and the most beneficent. My name is Engineer Nasir Ali Khan, and my fellow is Engineer Shoaib Ahmed. Today we are here to present our final year project presentation, which is titled as Smart Energy Monitoring and Controlling System, which is supervised by worthy and notable Dr. Suresh Kumar and Dr. Mohammad Waqas Subro. So moving on to the outline, we have introduction, motivation, problem statement, literature review, aims and objectives, methodology. After that, we have results and discussion, conclusion, future recommendation, and references. So moving to the introduction, as we all know, energy is very important for aspect for any household, industry, agriculture, and another applications. Managing the energy efficiently and conserving it intelligently for appliances is also very much important. As we all know, Pakistan is already suffering badly from the energy shortages, and it is estimated that average household wears 25% of the power. So, in the market, some devices are present through which you can control the appliances. From them, some are Google Home and Alexa, but they have some limitations. These things cannot turn off automatically non-essential appliances at peak hours. Also, they cannot turn off the appliances when our load exceeds then our desired highest value. According to the PEPCO, Pakistan Electric Power Company, it has presented some tariffs for peak hours and off-peak hours. Power taxes are allowed during the peak hours. So let's see. We have the power unit rates according to the units consumed. Like 1 to 100 units, we have 5.79. From 100 to 200, we have 8.11. And from 200 to 300, we have 10.2. So we can see as the power is increasing, as the units consumed are increasing, our unit rate is also increasing. But for the peak hour, in the peak hour, our unit rate is 20.7, which is a lot higher. Also, we have in the off-peak hours 14.38. So we have to consume energy in the off-peak hours rather than in the peak hours. Our motivation is to conserve the energy, also to reduce the bills of the electricity, and more importantly, the efficient use of appliances. One of the most challenging so the problem statement is that one of the most challenging tasks is to overcome the misuse of the energy and to monitor the energy consumption, as well as control the energy consumption in the peak hours. The second most challenging task is that IoT smart system to share its data on a secure server. So that IoT smart system to share its data on a secure server from where the user can access it easily. So the literature review part, first paper that we have is from 2020 and the authors are Paliwal and all. The title is Internet of Things Best Smart Energy Metering. And the description is that to collect, in this paper, the work has been done to collect the customer's power consumption data. An IoT based smart plugin has been employed. The sensor node hardware consists of the diverse parts, including current sensors, brightness sensors, and gas leakage sensors. The data obtained can be used to predict consumers' consumption and consumption timetables. This system shows the energy consumed on a normal, then it helps to cut back by the comparison day-to-day norms. So in that we have the first paper. The second paper that we have is from 2019. So it is written, the author is Rajendra Prasad, and the title is Internet of Things Based Home Monitoring and Device Control using ESP32. And the description is that MIT has developed a system which can monitor and control multi devices at home using IoT. The system works in three phases. In the first phase, the system monitors temperature, gas leakage, and water level. Second phase controls the motor pump and gas knob. And the gas leakage is detected respectively. The third phase, user control the home appliances like fan, light, etc. using the mobile app. So this is the work that has been done in the paper of the Rajendra Prasad. We have the third paper of 2017, and the author is Narendra Kumar Sahani, and the title is IoT-based Smart Energy Monitoring. And the description of this paper is that the proposed system utilizes the digitalization of load and energy usage reading over the internet. The user can monitor energy consumption in watts from web page by providing a channel ID of the load. The system consists of two parts, the first part being the physical part and the second part is the web page. It consists of the Arduino Nano board, ESP32, Wi-Fi module, 16 by 2 LCD, buzzer and power supply. So the fourth paper that we have is from 2019 and it is from Kalirajan KI and all. And the title of this paper is IoT-based Smart Energy Meter Monitoring and Controlling System. The description of this paper is that the smart meter will monitor by using Arduino Nano controller that is 8 Mega 32. In the previous paper we had ESP32. So the power meter will read the pulse to calculate the amount consumed by the power. LCD has displayed its IP to connect the module to send the data to the processor. It can transmit the data to utilizers and it also can receive information from utilities by making this thing the energy will be monitored. So that was all about the literature review. Now we have our aims and objectives. Our aim is to design and fabricate the smart IoT based energy meter and load controlling system, which has some objectives. And the objectives are energy conservation and monitoring, real-time data acquisition on the server, controlling of equipment through network, and load management. These are our objectives. So the methodology, we have proposed a solution titled a Smart Energy Monitoring and Controlling System. Our model consists of the real-time energy measuring and monitoring through the server, ThingsSpeak, and an Android mobile app. All the steps such as energy metering, displaying, transferring to IoT cloud and mobile app are discussed in the flow chart that we have in the next slide. In our proposed solution, we have designed smart energy monitoring and controlling system. Our system consists of two parts. First is primary circuit, second is secondary circuit. So moving on to the flow chart, we have first the energy meter that will send data to the ESP and ESP will send data to energy meter. And these are connected to the cloud and the mobile app. And basically what it does, it will check the peak hours. If there are peak hours, then it will check the power limit that is input by the user. So if the power limit is greater, then it will turn off the non-essential loads. If the power limit is less, then it will keep continuing the essential and non-essential loads. After that, if there are no peak hours, like in the off-peak hours, first what will it do? It will do first it will check the power also. If the power limit is greater than the user's defined value, then it will turn off the non-essential loads. And if it is less than, then it will keep going on the essential and non-essential loads on. So this power limit will be changed from this power limit. As in the peak hours, we will have a less power limit, and in the off-peak hours, we can have a greater power limit. So energy monitoring system, this is our primary circuit. What it contains an ESP, CT, current transformer, and the PT, which is potential transformer and the supply of 220. It will sense and measure. After that, it sends the value to the ESP and it will send to the cloud. Also on the mobile app. The primary consists of the ESP32 current transformer and voltage sensor PT. In the load controlling system, which is our secondary circuit, we have ThingsSpeak, which is basically a server, ESP32, amplifier circuit, relay, and load. Secondary system is basically controlling system that controls the appliances. Secondary system consists of ESP, amplifier circuit, mechanical relay board, and ESP32 is used here to execute the command given by the user through Android app. It gives command to the relay and that's how connected load can be turned on and off. So we can control the load. And the amplifier circuit we are using because the ESP32 pin can give only 3.3 volts, but our relay functions at 5 volts. So we have used an amplifier circuit to boost the voltages from 3.3 to 5 volts. So coming on to the results and discussions, we have divided our results into 4 portions. Our first portion is hardware results, serial monitor results, ThingsSpeak results, and in the end we have mobile results. So moving on to the hardware results, this is our primary circuit and this is our secondary circuit. We have already discussed the primary circuit and its working, and also the secondary circuit and its working. The primary circuit shows real-time volts, amperes, and watts. These are the volts, current, and the watts. It also sends data on server and also on mobile app. So the serial monitor results. On the serial monitor, we have used Arduino IDE, which is a software, free software platform. And on this serial monitor, we can see the peak hour limit that is defined by the user from the app, and also the off peak hours. It also tells our time, day, and if our peak hours are there, and also if there are no peak hours. So it also tells when the motor is off, or any appliance is off or turned on. So moving on to the ThingsSpeak results, we have on ThingsSpeak, our volts are shown, our amperes are shown that are consumed on real time. The above results are taken from the server ThingsSpeak. One can see volts, amps, and watts on server. This is our power graph that is showing the current power that is being consumed. Like at this point, the power is being consumed 287. The same graph is also shown on the app for the user's convenience. In the mobile app, this is our mobile app. In this mobile app, we have different functionalities and different options. First is our power. It is being shown on a real-time basis that how much power is being consumed. Also, there are 3 devices, fan, motor, and bulb. And your user can declare necessary and unnecessary any device according to his needs. Also, the devices can be directly controlled through these buttons, which are on and off. You can directly turn on and directly turn off any device that you want. In the last, that you can set the peak hour limit. The peak hour limit will be set by the user, and the off peak hour limit will be set by also by the user, and then you can sign out. It also shows some notifications, like when the device is being declared necessary, it will show the declared necessary, and after that it will show the declared unnecessary if the device is being declared unnecessary. Also, it tells when some appliances are off, like motor is off, where we have pushed this button, so the motor is off, it is showing, and we have pushed this button when the motor is on, so it shows the motor is on. So these are our mobile app results. So after the mobile app results, we have results taken without our proposed solution. So we can see a daily load curve without our solution if our proposed solution is not implemented. Like we experimented, this figure shows the daily load consumption of a room without our solution. As we can see, load is not changed throughout the day. It is continuously on 300 watts. Either it is off peak hours or peak hours. So the load is continued, and in this scenario, our unit rate is high. The load is not changed throughout the day. But what if we use our solution? Results taken with and without proposed solution. And in this, we have our solution implemented in our room, daily load curve with our solution. So this is the daily load curve. In this, we set the peak hour limit 110 watts, and the peak hours are from 4 to 10 p.m. as we can see in the graph, 4 to 10 p.m. And our limit is 110 watts. So we can see in the graph that the limit and the power has been reduced, and it has come to the point 110 watts continuously, and as the peak hours are off, then it goes to the set limit. So the consumption is also reduced according to our set limit. So these are the results that if our device is implemented, we will get these results, and these are our aims and objectives that are being achieved here. In the conclusion, we have designed and fabricated a smart energy monitoring system and controlling system. As a result of this, we can reduce energy consumption during peak hours and reduce the tax we pay for electricity consumption. This system is mainly designed to conserve energy by efficient use of appliances in residential, commercial, and industrial areas. Our project is following features. One can declare the appliances necessary and unnecessary according to his will. Also, one can limit its daily consumption during peak hours and off peak hours. One can monitor real-time energy consumption via server and Android app with the things that we have shown already. One can also control appliances remotely by using internet. So this was the conclusion and the limitations that our product has or this prototype has. There are four major limitations. Without internet, our system cannot work. Like the internet is very much important. And you can only monitor the total running load, not the consumption of the whole day. Moreover, new appliances cannot be added with a mobile app unless they are not programmed. So this is our limitation. Rating of the load cannot be changed from the mobile app unless it is programmed. This is also our limitations. But in the future recommendations, our developed prototype can become more efficient if the said limitations are encountered. Energy consumption in kilowatt hour of the whole day can be measured in the future. More options can be added to the Android app, like device rating can be input by the user. A message can be sent to the user when appliances turn off or on anytime. Devices can be added by user directly through the app. A protection system can also be added in our system to protect the devices from occurring any kind of fault or high voltages due to any reason. In this system, one can set the limits of devices as well. Moreover, an algorithm can be made to use this device in the absence of the internet. So these are the future recommendations. So these are the differences, and thank you. That's all.